Grandma, please.
Okay, start.
All right. My name is Alex Barbera, and we are doing the balloon geometry lab. So for this lab, literally all that is needed is a bunch of balloons. So I'm going to be explaining the different electron geometries for this. The different electron geometries is also known as Vesper. So in this activity, each balloon represents an electron domain. It will be either a bonding pair or a lone pair of electrons surrounding a central atom. So when connected, balloons naturally adopt the lowest energy arrangement predicted by the Vesper model. So Vesper stands for valence shell electron pair repulsion. This is the model used to predict the shapes of covalent molecules and polyatomic ions. This model is useful for predicting geometries of molecules with a single covalent bond around a central atom. It is based on the idea that bonding and lone pairs in the valence shell of an element repel each other and want to be farthest apart as possible. The positions assumed by the valence shell electrons determine the bonding angles. This can be illustrated with the balloons that I have here. So, I have two balloons right now in my hands. If I was to tie them together and have this, we would see that they were equally far apart, and this is a linear, and it has a bond angle of 180 degrees. Now, if I was to add in a third balloon, we now see that the bond angle will have shrunk, and it is now a 120 degree angles, and this is called trigonal planar. Adding a fourth balloon, we see that the bond angles will have shrunk to even more, and the fourth balloon has a bond angle of 109.5, and this is called tetrahedral. A fifth balloon has a bond angle of 120 degrees, and this is called bipyramidal. And then lastly, adding a sixth balloon to it, it should not be looking like this, but if we were to have 6 balloons, each balloon would have an angle of 90 degrees, and this would be called octahedral. Thank you for listening.